This is Algebra 2, Lesson 1-6, Video B. We're talking about solving absolute value equations, and in this video, solving absolute value inequalities. So an absolute value that is a less than or equal to, or another value is an and problem, and that graph actually gets shaded in the between the endpoints. We've talked about that before. So and problems are less than or equal to. Then an absolute value that is a greater than or equal to x becomes an or inequality. And so the graph will be shaded to the left and to the right. So it says write an absolute value inequality and graph the inequality on a number line. A person's checking account varies between $4,000 and $10,000. So we know that this person's checking account is going to be between 4,000 and it's going to be between 10,000. That's a pretty basic, just kind of quick review. When we graph that, remember we're going to graph a point at 4,000 and we're going to graph a point at 10,000. I've got to think about, we're going to have those values. Is it open or closed? Well, I would say it's between those, and so it's going to be open because we use the less thans and we shade in between. So that's your basic and inequality. Now here we have the absolute value of x is greater than 5. So when we write this one, whenever you see an absolute value, it tells you right off the bat you're going to have two separate equations or two separate inequalities that you're going to have to write. The first one is what you see without the absolute value sign, so x is greater than 5. And then you also need to have the opposite of that right side, negative 5. Now when you change that right side to be its opposite, what you actually do is you also flip the inequality sign. So it becomes x is greater than 5. And you also end up with x is less than negative 5. Now when we go graph those, we need a point at negative 5 and a point at 5 and a point in the middle, 0. You can see x is greater than 5 is an open circle pointing to the right, and x is less than 5 is an open circle pointing to the left. So if you are paying attention, then if it's pointing out, this is actually an or inequality. Now you can memorize that greater than or equal to are or inequalities, and less than or equal to are and inequalities, but you can also just kind of pay attention to the problem as you graph. So let's do this next one together. Absolute value of 4x plus 3 is less than 5. We're going to write it like we see it without the absolute value signs, and then we're going to write the opposite of that right side. So we're going to have a negative 5, and when we do that, we also flip the sign. So now we can just start solving these two absolute value inequalities. And they're just regular inequalities as we solve. And so we end up with x is less than 1/2 and x is greater than negative 2. When you graph those, you're going to have negative 2, 1/2. A good point in the middle maybe to have there. You could put in negative 1, 0. Oh, that's not a good spacing. Here we go. Negative 1, 0, and 1. You can kind of see that spacing. It's not my greatest spacing ever. Now we're going to graph those points. We have negative 2, which is an open circle, 1/2, which is also an open circle, and it's an and you can also tell from those inequality signs we're shading in between. So if it's an and inequality, you can also collapse it and say that negative 2 is less than x, which is less than 1/2. All right, you have one to do on your own here now, or two to do on your own here now. Pause the video and do these two on your own. You can see my work for this one. I started by moving that negative 5 over, so I got a 17 on the right side. I had my positive first inequality, and then where I flipped my sign and I took the opposite of that right side. I ended up with x is greater than 5 or x is less than negative 19/3. You can see my graph up there. Negative 19/3 is about negative 6.3 repeating, so I kind of put that in there. And then you can see the next one. I started by multiplying both sides by the reciprocal 4/3 to get rid of the 3/4 out in front, and we got left with absolute value of x plus 7 on the left and 32 on the right. Then I just started solving from there. I got x is less than or equal to 25, and x is greater than or equal to negative 39, which once again you could combine both of those into one compound inequality. Either one of those boxes will work for your answer, and then you can see the graph with closed circles shaded in between. Okay. So here it says write an absolute value inequality and a compound inequality for a length of 24 feet with a tolerance of 3 inches. Solve and graph your answer. So you'll see a situation like this actually in the real world in industry. They'll say, well, they need something to be about 24 feet, but it can be 3 inches more or 3 inches less. So if we start with this being an absolute value inequality, they're saying that, okay, we have to have absolute value. Our tolerance is that whatever we have, whatever product we create, it can't be more than 3 inches off of the original. And so whatever happens, it has to be less than or equal to 3 inches. Now, the one thing you might want to notice right off the bat is these units are different, 24 feet and 3 inches. I always start by changing that 24 feet into inches, so we're going to go 24 times 3, turn that into inches. The reason why I picked that one is that's going to be a whole number, whereas if you change inches to feet, you're going to end up with decimals you have to deal with. So we're dealing with 72 inches. Something is 72 inches long. Now, what we really want to talk about is 72 inches is the goal of what you're trying to produce. However, sometimes you get it off a little bit. And so that difference between what you actually have and what you want, it has to be less than or equal to 3. And so we can say, well, what I have is really x, and what I want the difference between that and that 72 inches. We end up with that absolute value inequality, saying the absolute value of x minus 72 is less than or equal to 3. Now, what happens when we solve this one is we take this and we turn it into two inequalities. X minus 72 is less than or equal to 3, and x minus 72 is greater than or equal to negative 3. When you solve these, you get some nice numbers. X is less than or equal to 75, and x is greater than or equal to 69. So what's really happening is that the measurements for your object are in between 69 and 75. So this is actually an and compound inequality, so you can write it as one compound inequality just like that. And so if your object is in between these two measurements, then it is acceptable and it can still be used for whatever purpose they have in mind. So you're going to put closed dots and shade in between. If you have questions on that, ask me. We can talk about it some more in person. All right, that was the last of Algebra 2, Lesson 1-6. Our topics were to write and solve equations, and in this one, specifically to write and solve inequalities involving absolute value.